Welcome to class. The topic is in data structures, we have yet another structure called union. We studied struct, that was the keyword used to create a compact data structure. Very efficient, very useful. In the first place, when you look at the union or start to implement, it resembles struct, the basic structure of C. Fundamentally, it is different. Unions in C are the data structures that allow different variables to share the same memory location at the same time. The elements within a union structure share the same memory location. Unlike structures that we studied earlier, where each member has its own memory space, union members actually, members of the union, the elements within a union, overlap. As the name states, it is a union. So these members overlap in the same location of the memory, and the memory allocated is equal to the largest member. Whichever member is the largest member of that structure is the maximum size of that union. This memory sharing enables efficient use of memory when only one member is active at a time, making unions useful for space optimization in certain scenarios. I mean, it has special uses. It's not something that everybody should play with. You will come up with a common solution that would be utilizing the unions. No. Unions have special usage. I'll give you an example though. However, it is essential to be, just while accessing the union members, and it can lead to data integrity issues if not handled properly. Of course, you have a larger element and you have smaller elements. You modify the smaller element, the beginning of the larger element would be corrupted. It will be modified. The middle-sized element is modified, the larger is modified. The smaller is modified, the middle size as well as the larger is modified. So anything modified anywhere reflects on all the members of the union because there is only one memory space that is allocated to it. I hope you understand. I'll give you examples. So how can we visually understand the union? Union structure is something like this. For example, you have the first element, which is 1 byte. Second element, which is a short. This one is a character. This one is a short. The second element that you have defined. The third is an integer. And fourth is a long, or maybe a double. Or any structure, any data type that holds 8 bytes. So when they are put together, they are aligned in the memory in this way. So any change that occurs over here in this byte is going to reflect throughout this. It's going to change all the bytes beneath it. This is how I could easily present to you. Is anything that is operated here is operated in all the first byte, first byte of all the elements that are along with that, within that structure. If the second byte is updated, of course, it will reflect in all the fields and practically updating in the final, which is the largest element in the union. So, third byte, 4 byte update, fourth byte updated. For example, you assign a value to integer, the whole integer is updated here. So if the whole integer is updated, so what happens is the first 4 bytes are gone. They're updated here in this largest structure, whichever that is. And amongst those bytes, 2 are updated here, and the first byte is updated here. So practically any change within any of the elements, for example, this is your 2 bytes, it's not a short, and you're using a character array of 2. You assign a second value on the second index, for example, here, when you do that, it immediately reflects on all these. It's updated in all this second portion, in second byte of all the elements which can hold the second byte. Of course, not the first one. If you just update the third one or the fourth one, for example, you update the fourth byte. For example, this is 4-byte character array. And you updated the fourth element on index 3. So when you update, it's immediately reflected over here. It's not going to affect the previous ones, of course, but it's affected here immediately. So the final structure that either you save it to disk or you read it from the disk again, you are going to get everything in here. This would be the maximum size of your structure. And I hope it makes sense. And on usage, actually, I did provide you a lecture. What can be the possible usage of it? If you did not understand anything, just let me know. Your final structure here is completely 8 bytes. That's it. It's compact 8-byte structure, totally saved, but we have distributed it amongst different elements to make it easy for us to distribute them amongst the different elements. If you do not understand anything, just let me know. I'll be answering in the forum. Thank you.